Okay, here we go. We're going to try and apply those remainder and factor theorems we talked about in class in order to factor another polynomial. It is degree 3 because we're the highest exponent on any variable is 3. Um, this one is also, we also given the information that f of negative 6 equals 0. So if we actually broke this one down and tried to factor it using techniques from before, it does have 4 terms. We would try the grouping process, but what you would see is the grouping process does not work in this case. Um, so before we would have had to say that this thing is just non-factorable. We can't break it down any further, and since it's degree 3, we actually don't know how to solve those at this point um, with any other method than factoring. So they gave us this little extra information here, and this says f of negative 6 equals 0. And what that means is if we plugged in negative 6 for each x in the polynomial, we're going to get 0 for f of x, or which also means y, which means that x equals negative 6 is a solution to this polynomial. That means it's a 0 or an x-intercept also. If you think about these things graphically, what we're able to do with this is we can actually take any solution or 0 of a polynomial and turn it back into one of its factors. And we can do that by just adding 6 to both sides of the equation here, which would produce x plus 6 equals 0. And that is then actually one factor of our polynomial here. So what we're going to look at doing is dividing out this x plus 6 from the original polynomial to see what we would need to multiply this by to get back to here. In other words, we're just going to start listing out its factors. So we have, I'm just going to write an expression here, but we have a 3x cubed plus a 14x squared minus 28x minus 24. We already know that x plus 6 is one of its factors. So what we want to do is actually divide that out of there. So we're going to go ahead and use our long division techniques. There is synthetic division we could use as well, but I just like to learn one method if possible. But we'll go ahead, divide out the x plus 6, and we'll see what's left here. So we're going to go ahead and look at the first term of the divisor and the first term of the dividend, and we'd say what times x equals 3x cubed. And if we figure that out, we would see that we would need to multiply x with a 3x squared. Remember, you add the powers, multiply the numbers. So if we distribute this, we'll get a 3x squared times x is 3x cubed. 3x squared times positive 6 is positive 18x squareds. Okay, don't forget you are subtracting the polynomials here, so we need to make sure we distribute that negative when we're doing our subtraction. But 3x cubed minus 3x cubed is 0x cubes. 14x squared minus 18x squared should give us negative 4x squareds. Okay, at that point, we can go ahead and drop the next term. Okay, and we repeat the process we just did. Look here, and we say what times x is negative 4x squareds. Well, in that case, we're going to need a negative 4x. Okay, distribute the negative 4x through our divisor. Negative 4x times x is negative 4x squareds. Negative 4x times positive 6 is going to be negative 24x's. Again, subtracting polynomials, distribute the negative. Careful, negative 4x squared minus negative 4x squared is 0x squareds. Negative 28x minus negative, so that's really going to turn into addition there. So it's negative 28x plus 24x should give us negative 4x. Okay. We can go ahead at that point, drop the next term, negative 24, and repeat. Look here, look here. What times x is negative 4x? Well, in that case, we're going to need just the negative 4. Negative 4 times x is negative 4x. Negative 4 times positive 6 is negative 24. And just like we assumed or should know that should happen here, this should just leave us with a remainder of 0. Again, if that's a 0 and that's a factor, if we divide it out, it should come out a whole number of times. Okay, nothing left over, no remainder. All right, so now it's just a matter of interpreting kind of what we just have shown here. And the divisor and the quotient, or the answer, should be factors of what got divided. So our original polynomial is now factored into those two expressions. So the divisor is the first factor, x plus 6. The second factor is now what was left of the whole number, the quotient here. And then hopefully what we're able to do is break this one down even further. We always got to check. If we can't, hey, there's our final answer. If it can be factored again, we do need to do that. So this is a three-term factoring. That's the quadratic form factoring. Write it as the product of two binomials. So our first need to multiply to make first, which got to be 3x and x. There's no other possibilities. Last are factors of 4, which could be 4 times 1 or 2 times 2. I'm going to check the 2 and 2 first. So we go 2 here and 2 here. The outsides will give us 6 x's. The insides give us 2 x's, which does make a 4 if we can get the signs to match up. And since the last one's negative, that means we do need one of each. The middle one's negative, so we're going to put the negative on the outsides here because that's going to give us negative 6x or more x's, negative. And this one, we put the positive here on the inside, which gives us positive 2x. And there we go. I think we got it factored down. Each of those factors is now linear, or first power, x to the first, x to the first, x to the first, which means they will not factor any further unless there was a common monomial in one of them. So hope that helps. If you have any questions, feel free to email me or see me before class. Thanks.